Here we want to take a look at conditional filtering, and we will take a look at Boolean indexing. So let's continue with where we stopped in the last video. So let's run this. Let's say we want to take a look at a case where the age is greater than 30. So if we simply run that, we can choose that column. However, within that column, we can play with a condition. So let's say age greater than 30. So if I run that, you can see it will tell me if that's the case. You can see the first one, the age is not greater than 30. Here it's greater than 30. You can actually take a look at the data and you will see if we take a look at the age. Okay, let's run here. Age 22, age 38. So this is false, this is true. So that's what we got here. So it's giving you the Boolean response to your question for you to know if that holds or not. Now, on the other hand, we can actually take a look at older passengers. So if we are looking for passengers who are above that age, so df log, of course, this time we can just use the square bracket to go and pick them out. So here basically we'll say df log. So within this, we'll put the condition in there. df log, we are interested in the age, and we are interested in the age that is greater than 30. And if we want, well, we'll just stop there. And here we have older passengers. We can actually say head and then run it and see what happens. And there we go. If you take a look at the age, you'll see that we only have ages higher than that. So if you want to do that, and if you want, we can also create younger passengers. That's pretty straightforward. If we just copy that, I strongly encourage you not to copy it, to type it, because the more you do those things, it sticks. Younger passengers, younger passengers, and here it's going to be less than 30. Okay, what if someone is 30? So here we'll say less than or equal. Let's just leave less than. If I run that, here we go. If you take a look at the age, you will see. Now let's just take a look at the number of younger and older passengers. So if I want to take a look at the age, print, so I'll say older passengers dot shape. If I don't use print, I can't put them side by side. Then the latest one will just not let the earliest thing come out. So you can try to do it without a print and you'll see how it looks. Okay, there we go. We can see we have 305 rows of older passengers and 384 rows of the younger ones. What if we want to see if actually a passenger is 30? Let's just do df log, Okay, this time we are not saying, we are saying if the person is 30. Let's run and see. So these are the people who are 30, and So let's just put them inside something. Let's say aged 30 equal, and then we will have shape. Actually, it's aged 30.shape. Then there we go. We have 25 of them aged 30. Now note, if you put equal, then you are assigning 30 to this. Then inside this, you are assigning age to become 30. You don't want that. That's why you use equality. This is an equality, but if you use only one equal sign, it becomes an assignment. So there's an interesting one to take a look at. For example, if you do df log and you take a look at the columns, if we're on that, you can see survived. So let's take a look at this survived to see what is actually there. So if we do df log and we say survived, so IntelliSense helps suggest things for you. So I'll say head, and I run it. You can see it's either 0 or 1. Now 1 means they survived, 0 means they died. So if you want, now we can say survive. Let's see the number of people who survived. Then we'll do df log. This time it's going to be, you want them to be 1, and it's not age, it's survive. So you want to extract those who survived, and also we will not say died, we will say not survived. Not survived. So here we will change it to 0, and at the end we will have print so that we can see both of them. I'll say survived dot shape, and the other one will be print not survive dot shape. Then we can run it to see. So you can see the number of people who survived and the number of people who are not part of survive. So interesting. Now, an interesting question is, among those who survive, were they only the rich people? What type of cabin were they in? You can now study it from that. Now, let's say sex. Among those who survive, what was the sex? What was the age? So what was the dominant age group and sex among those who survive? You can play such things with it. So for example, you can come and say survived. Okay, let me not get into analyzing the data. Here I'm just showing you how to filter things. Let me stick to it, else we get lost and we start analyzing the data when it's not yet time. Anyway, I want to show you how to use more than one condition, so we can still use it to play around with it in that context. So among those who survive, let's look at those who are female and are less than 30, as well as those who are male and less than 30. We already know the size, so that will be very helpful. So we will be using survived. So let's use the survived data. So I'll just call this df. No, I'll say survive young female. Okay, let's put it like that. So here we have survived, because this is now the data set this is the data set we derived from there. So it's going to be survived. Now it's important I put it around a parenthesis if I'm going to use more than one. Okay, so I'll say Hold on, that's not what I plan to do. I want to put it within a parenthesis. However, it's going to be in brackets. So we have survive. Now, what are they using? Survive sex equals female, and then survive age less than 30. Okay, so sex equals female, and the other one, we always wrap it in this thing, given that we are using character. If it's just numbers, you don't need to wrap it there. Then we want to do exactly the same thing, and we open another bracket. It's going to be survived age is less than 30. So let's take a look at the size of that. Survive young female dot shape. Okay, so of all those who survive, this is the group. Now let's just rerun this. I'll just put them side by side to see of those who survive. We want to see the proportion of male and female. So young female, I'll say young male. In this case, let's put male, and run it. We will print survive young male dot shape. So here we have the young male, the young female. Then we can also look at the same thing for older. Older female, older male. In this case, it's going to be greater than 30. So I will say greater than or equal to 30, greater than or equal. And here we want to add some more. Here we'll have O and then O. Let's run it and see. So now we have 105 young female, and these are the number of. So basically you find that the total number of female, a larger proportion, close to 200 were female and less than 100 male of the total number who survived. And the highest percentage of those who survive were the young female. So it's an advantage to be young and female, then you have a higher proportion of surviving in some of those things. Now, an interesting situation is to look at the class. So if we, for example, so if you remember when we run this, you can see the class. Is it first class, second class, or third class? That's an interesting thing. So you may check who are those. Is it only the rich or the less fortunate who survive? So let's just run something in general. We'll run it on the whole data set. So if I do dflog dot, if I choose that column of P class. Now, what if we want to see the classes which are there? So if I say if I run this, it's going to, okay, let me not say if, so you can see what comes out. Okay, these are the things in the classes, but what if we want to see the unique classes which exist? All what I need to do is to say dot unique and use the function unique and then run it. There we go. This is what we have. And we could as well do the n unique. Let me say n unique. We had seen that in one of our classes. So we have only 3 classes. We have 3 distinct classes. We have these classes which exist. Okay, so now let's take a look at those who survive. Which class survived? What's the distribution of these classes among those who survive? So let's say survived class 1, and then we will have survive class 2, and so on and so forth. Okay, so for that, let's go to survive. So the condition will be the survive being in that class. Survive. So I'll say P class. And in this case, we are saying the class is 1. And we can say print survived 1 to see those who survived and who were of that class. So we are going to do it the right way by putting everything together as it should be. So in this case, I'll just get rid of that. Open, and we will do it similar to what we initially did. So it's going to be survived. So I'll just take that and then do the changes. So let me explain this. Survive is the survive data set we are using. Okay, this is the survive data set. Inside the survive data set, we have a column known as survived. It starts with capital and then it's 1. So remember, survived, this is it. Where did we put it? You have it here. So within the data set, here we were using dflock, here we are using survive. Within this, we are taking this, and we will also take that. So we are saying if the person survive, we know here they survive. That's why we have the survive data set. So we are saying if they survive, and within the survive data set, we want to look at the cabin class. If the cabin class is 1, then we want to see how many were in it. Shape. Then we will do exactly the same for the second one. I'll paste it, and I'll paste it again. I strongly suggest you do not do that. Okay, I guess I pasted one in the wrong spot. Type it, and type it. It's very important for your learning. First, you'll type faster. Secondly, you'll try to understand what's going on. So there's no need running, completing the exercises and not fully understanding it. So let's make this 2. And here, this is the third one. So if I run it, now we can see that in cabin 1, 136, in cabin 2, and the other cabin, that's it. So the majority of those who survived in the first cabin. So it's as if being in first class helps. Now let's actually take a look at those who survived who were kids. Let's take now we will not use survive, we'll just take the DF log, and we want to see those who survived who were kids. So we will do the same thing, DF log. I'll say survived, and I'll say and open another one, DF log. This time we want to throw in age. Do we have those who were under 18 here? And I'll say shape. Let's see. So we can see that 61 kids survived. Okay, 61 kids survived. Now, what if let me see. Okay, let's just leave it like that. 61 kids survived. Well, another interesting question. Do we have kids who did not survive? So let's run it and see. 52 kids did not survive. That's interesting. I would like to know in which cabin were found the kids who survived and the kids who did not survive. Okay, let's just throw in that. It's a bit heartbreaking, but let me throw this again. I'll say DF log. Actually, I had never done this analysis, so I want to see the class. I'm just asking myself these questions as we play around with it. So those who did not survive, I want to see if if any kid did not survive from first class. One kid did not survive from first class. How many from second class? 2 from second class. And how many from third class? Oh my God, 49 from the third class. So this is insane. Whatever. So if you are a rich kid, you survive. If you are not a rich kid, tough luck for you. Now let's take a look at another approach where you want to use is-in. Very important method. So all these things we've done in this session, you just have to master them, do it over and over and over. Then you'll be able to clean your data in your sleep, clean, subset, and select the data before you even start analyzing it. It's going to make life so easy for you to answer any question you want to answer. So before we move on, we just want to take a look at something. DF log. So here I want to take a look at embarked. So embarked, let's look at the unique values which are there. Actually, let's just run it like this and see what's in it. Embark, you have all this code. It's showing you where people got on board. For example, Q is Queenstown, C is Sherbrooke. So you can go online and look at the meaning of all of that. Let's take a look at the number of unique values we have. If we run it, we can see the number of unique values. Okay, we have some problems here. Let's just go for unique. And let me see what's going on here. Very easy. I have to be careful. We need to put a bracket and run it. So these are the unique values. We have S, C, Q, and we have some missing values. So if we do the same thing, DF embark, DF lock, embark, and then we do the dot non-unique, then we will see that we actually have, these are the values we have. So let's just play around and see where people embarked, maybe where, in which cabin they were based on where they embarked, or if they were first class or second class based on where they entered the ship. Okay, before we do that, let's just take a look. We want to look at the passengers who embarked from these places. That's basically what we will try to do here. And it's pretty straightforward. So we'll just call it embarked CQ. And for that df lock, this is not what we want here. So we will take embark. Hold on, this looks strange. Okay, we'll open a square brackets. Then we have df lock, and then we have another square bracket. Now within the square bracket, we want to take the embarked. And where do we want it to be? We are not just going to say do something like that and put 1. So we will use is in. So it's going to be is in a list. Okay. Then it will check. If it's not in that list, it's not going to keep it here. But if it's in that list, it's going to keep it there. So what list do we have? We have C, comma, we have Q. Now, by the way, we know we should have SCQ, but we just want to keep these two. So it's going to check under embark, whatever is only part of this, it's going to keep it in there. Then we can play around with it. So now we can now do the embarked. And I can just say shape to take a look at it. Actually, it's embark CQ. This is okay. Awesome. So the majority embarked from there. Okay. Now, there's an interesting thing we can do. We can now look at the proportion that embark from each of those places. So here we can simply do the embarked CQ. Now we simply need to come, because if you run, for example, if I say hit here, you'll see that it's the whole data set, but we want to focus on embarked. Okay, if you scroll, you'll find embark is somewhere there. We want to focus on embark, so I'm going to open that, and then I'll take embark. However, it's not just this one I want to focus on. I want it to give me the proportions of each. So what I'm going to do is I'll use value counts. So let's run it. Now you can see that we have 169 and 77 coming from each. So this is, you can see the number coming from the different places. Now we can actually make it better by coming here and saying normalize equals to true. So if we do that and we run it, you'll see that it gives us the proportion, and you can actually multiply that by 100, and that is what you are going to have. And if you want, you can actually round the whole thing into a round thing. And let's see if I do round and I open and I close it here, but here I decide to say comma 2. So here you can see how your thing looks like. So you have 68% that embark there and the other percentage embark there. Now we have been using this data. Now if you change from embarked and you just use df log and we run it, then you have all of it. You can see 72% embarked from S, 18% embarked there, and that percentage of the overall embarked from there. Okay, that's it.